All right, in this lesson, I'm going to teach you to factor by grouping. Grouping is when you put certain things together. We're going to group in pairs. So two terms will be together. Two terms may be in one group and two terms may be in the other group. It's actually a grouping in the GCF. We're going to group and then we're going to use the GCF. Okay, guys? All right, let's get started. Sometimes the GCF of terms is a binomial. So in the last lesson, the GCF was just some monomial. It was just one term. But sometimes the GCF is a binomial. This type of GCF is called a common binomial factor. So when you see a common binomial factor, you factor it out as you would any other common factor. So I'm going to show you exactly what I'm talking about. Look at this expression here. It says factor this expression. So I pretty much have it already set up for you. I have it grouped. I have this term grouped with this expression and this term grouped here. But if you look between both of these, and I'm going to highlight them, you should see a common binomial factor. All right, so here and also here. You should see a common binomial factor. Okay, so what binomial do you see that they have in common? That would be x plus 6. See, x plus 6 is here, and x plus 6 is here. So we'll say the common binomial factor is x plus 6. And you all pause the video and take notes in your notebook too, okay? So just like I normally, in the last unit, I normally divided by the GCF. Now I'm going to divide by this common binomial factor. So I'm going to divide here by x plus 6. And I'm going to divide here by x plus 6. Well, if you notice, these cancel each other out. And all you're left with is 4x. And then if you notice here, these cancel each other out. And all you're left with is minus 5. This is your remainder. So what you're going to do now is you're going to write your the factor form like such. It's like this. You're going to have the common binomial factor. And I may have this written somewhere else in the notes. It's going to be the common binomial factor all times the remainder. So that would be your factored form for these, okay? Not factor form, factored form. So if I get ready to write this in factored form, I'm going to write x plus 6. That's my common binomial factor. And then the remainder is 4x minus 5. So this is what we would call factored form. Now, I'll be honest, guys. It doesn't matter which one of these factors you write first. You can swap this around. So instead of writing the common binomial factor first, then the remainder, I can write the remainder and then the common binomial factor. So I could have switched these around. I could have written 4x minus 5 times x plus 6 instead of x plus 6 times 4x minus 5. Okay, let's take a look at this one. All right, you should see a common binomial factor. All right, so in each one of these. So here and also here. Okay. All right, so I hope everybody sees x squared plus 4. I mean, it's jumping right out at you. You should see it. So the common binomial factor is x plus 4. This thing is not wanting to write correctly. It's not x, but x squared plus 4. So what I'm going to do is I'm going to divide each one by x squared plus 4. I'm going to divide this by x squared plus 4. And I'm going to divide this by x squared plus 4. All right. Now, these are going to cancel, leaving me with negative x. Okay, but both of these cancel. What happens? What did I tell you all happens if everything cancels? What do you have to write? You have to write a 1, okay? Now, what I could have done is I could have put an imaginary 1 in front of that parentheses and then canceled to help me see that I should write a 1, okay? Okay, so this is my remainder. So when I write this in factor form, all right, the common binomial factor, which is x squared plus 4 times negative x plus 1, the remainder. And that's it. I wish it wouldn't make those markings like that. You can't really tell what the number is. Okay. All right, so let's take a look at this. When a polynomial has 4 or more terms, you may be able to factor by grouping. Just make 2 groups and factor out the GCF from each group. So we're going to use grouping and GCF, okay? We just call it factor by grouping. So the strategies for factoring by grouping, and I'm going to tell you something, these look different from what I gave you up here. But you'll see why I gave you these after I start going through the process of solving this, okay? I'm not going to say anything right now. You'll understand. All right, so the strategies for factoring by grouping. First, A, group terms that have a common factor. So you're going to group them in pairs. Like you have 1, 2, 3, 4. So this is only going to work. You can only do this when you have what? 4 or more terms. We're just going to be dealing with 4. And I got 1, 2, 3, 4. I'm going to group them in pairs. And I'm going to highlight my pairs. Some teachers will have you put parentheses around them. I just highlight them. Or I underline them. But if you have a highlighter, that would probably be good if you could write it out and highlight the pairs you want to put together. So you're going to put pairs together. Then you're going to factor out the GCF from the first group of terms that you have as well as the second group of terms. So basically your two sets of pairs. You'll factor using the GCF. Then you're going to factor out the common binomial factor. By the time you do B, part C, when you do part B, it's going to end up looking like this. And you should know what to do from there. Okay? Factor out the common binomial factor. Write it in factor form, which is the common binomial factor times the remainder. Okay, so let's take a look at it. I'm going to group, but I highlight mine. So I group things that have something in common. Okay. I group things that have something in common. And I'm just going to highlight or underline. So I'm going to group 12a cubed and negative 9a squared. And then I'm going to group positive 20a to the 5th, positive 20a minus 15. Guys, it's 1:29 in the morning. But I don't want to do any work tomorrow, so I'm trying to get it all done now. All right, so if I make a mistake, just bear with me. All right, so now since I have the groups, I'm going to do the group in yellow. So I completely ignore the group in blue, the 20A minus 15. Okay, I ignore that pair. Pretend like you don't even see it. Matter of fact, if I had something to cover it up, I would cover it up. All right, so we're only going to focus on 12A cubed minus 9A squared. Just that part. So I'm going to put them in different colors, so maybe this will help you. All right, so between 12 and 9, the GCF, well, the biggest number that will go into it, the greatest number that will divide into those is a 3, okay? And then you have A and A in both of those. So since you have an A in both, you can go ahead and write an A as part of your GCF, but choose the one with the smallest exponent. A squared is smaller than A cubed. So your GCF is 3A squared. So only focus on the part in yellow. That's why I highlight. It makes it so much easier to organize it. You're going to divide each part by 3A squared. Okay, notice I'm not even touching the part in blue. I'm not touching that pair, okay? Not right now. I'm not even worried about it. 12 divided by 3 is 4. And because I have an A in the numerator and an A in the denominator, I can subtract 3 minus 2, subtract the exponent. 3 minus 2 is 1, so I end up with 4A, or 4 to the first. Negative 9 minus 3 is negative 3. And these two basically match. They cancel each other out. So when I get ready to complete this part in yellow, all I need to do is write it in factor form. So the way I did in the last lesson. So you take your GCF, which is 3. Please write. There you go. 3A squared times the remainder. And this is your remainder, guys. Times 4A minus 3. Okay? That's all you want to do with that part. You just want to factor that pair. Okay? Now you want to factor the other pair. The other pair is in blue. So I'm going to factor the pair in blue. Okay, I'm going to do this. Just working on the pair in blue. I'm chunking it. Just keeping it separate for you because I don't want to confuse anybody. So your GCF. Can I get back to my pen? Thank you. Okay, thank you. My GCF between the numbers 20 and 15. Okay, so between 20 and 15, what is the greatest divisor? Well, that would be a 5. Well, if you notice, let me do this in different colors too. If you notice, this one has an A and this one does not have an A. Okay, over here. There's no A. So I don't worry about putting A as part of my GCF. So basically, I just divide by 5. Divide each of these pieces by 5. Okay? Not worried about the block in yellow. Not doing that pair. I already done it. Don't worry about it. Just work on the block in blue. All right, so you end up with 4A. When you do 20A divided by 5. And then negative 15 divided by 5 is 3. Okay, this is your remainder. Please pick the GCF of that pair. The GCF that pair was in the blue block, which is 5. So you end up, and I'm going to put a sign in front of it, guys, because I need a sign in the middle. 5. Well, 5 was positive. So since 5 was positive, I'm going to put a plus right here. So plus 5, and then times the remainder, 4A minus 3. Okay, if you notice, all of this should look familiar now. Okay, all of this goes back to this. So this is why I showed you this first, because you should be able to see a common binomial factor now. You should be able to factor it out. So I'm hoping it makes it easy for you. Do you see a common binomial factor? Yeah, I see a common binomial factor. See, The binomial 4a minus 3 is in this group, and the binomial 4a minus 3 is in this group. So what I'm going to do is factor out that binomial. Okay, now my common. Now I have a common binomial factor, which is 4a minus 3. So now I get to divide each piece by 4a minus 3. Go over here and divide by 4a minus 3. That leaves me with, because these are going to cancel. This cancels. This cancels. Okay. So I end up with a remainder of 3a squared plus 5. That's my remainder. So in factor form, I write my common binomial factor first. 4a minus 3 times the remainder. 3a squared plus 5. This is factored form. I hope it makes sense already. If not, we got more examples. But this polynomial is simply this in factored form. And if I were to use the distributive property, the double distribution, it would end up giving me that right there. Okay, but again, factoring is working backwards. Factoring is being given the polynomial and working to what you, the multiples of the factors, okay? What you multiply to get that polynomial. All right, let's take a look at another one. I got 6 of these things. I may not do all 6. All right. Now, let's go back up here and group. All right, so somebody's saying, well, how do I know what to group? Well, you group them the way they're set up. Normally, you just group them the way they're set up, unless you automatically see that they don't have anything in common, or others have more in common. Like maybe the first and the third term have more in common, and the second and the fourth term have more in common. And if you can't recognize that, then I suggest you just work them in the order that they are. The first two group, the last two group together. And if it doesn't work out, try regrouping them. All right, let's take a look at these. I'm going to group these two in blue, and I'll do these in yellow. Okay, I'm going to do my blocks again. All right, I'm going to do the blue one first. Okay, then I'll do the yellow one. And then I'll look at a common binomial factor. Okay, let's do the one in blue. Okay, the GCF. Okay, between 6 and 8, the GCF is 2, and then they both have an h. But you're going to choose h squared because it's smaller than h cubed. So what you're going to do is divide each one of these by 2h squared. Don't worry about the block in yellow. Not worried about that right now. Please don't do it. And I hope you all understand why I said get highlighters. It just makes it so much easier to do. 6 divided by 2 is 3. 3 minus 2 is 1. I can do that because both of those are h's. 8 divided by 2 is 4. And if you notice, these will cancel. They're exactly the same. They cancel. So in factor form, it's 2h squared times the remainder, which is 3h plus 4. Okay, got that done. Okay, now I need to work on the block in yellow. So the GCF, the block in yellow. Well, what do the 9 and the 12 have in common? What's the greatest divisor? Well, that would be a 3. Well, do they have any variables in common? That would be a no, because this has an H and there is no H there. So all they have in common is a 3. So I'm going to divide each of these pieces by 3. Oh my goodness. Okay, now divide by 3. So we'll end up 9 divided by 3 is 3. Bring down the H because there's no H to simplify with in the denominator. And 12 divided by 3 is 4. Okay, now you take your GCF, because we're working just on the yellow, and put it with the remainder. Now my GCF was positive. Oh my. Plus 3. So because it's positive, I put a plus right here. And then I put the remainder. The remainder is 3H plus 4. Now you should notice, I hate that 3's looking like that. I'm going to leave it. Everybody know that's a 3H plus 4. All right, so now what you're going to do is look for a common binomial factor, okay? See anything here that's over here? You should see 3H plus 4, 3H plus 4. So your common binomial factor is 3H plus 4. Oh, look at that 4. Okay, let me see if I can undo this 4. That's much better. Okay, so now what I'm going to do, and let me erase. I'm going to leave it. I'm going to divide by 3H plus 4. And over here, I'm going to divide by 3H plus 4. I was going to erase that arrow. And then I'm just going to cancel. This, I don't want to do the blunt. This cancels with that. And this cancels with that. Those two binomial factors cancel. And I'm left with, as a remainder, 2H squared. And then plus 3. That's my remainder. So when I write it in factor form, I write my common binomial factor, which is 3H plus 4. I'm sorry, guys. This thing is in slow motion sometimes. And then the remainder is 2H squared plus 3. Okay, now let's take a look at this next one. Okay, same process, guys. Like the process doesn't change. All right, so what we'll do, same thing. We'll group these. We'll find the GCF there. And then we'll group the last two. And we'll find the GCF there. Then we'll look for our common binomial factor. All right, so there's a 2, there's a 2. So the GCF definitely is a 2 between the coefficients. Each one of them have an x, but what you would do is between x cubed and x squared, choose the one with the smallest exponent. So choose x squared. Each one of them have a y. And so notice that's y squared and y squared. It's the same. So that's pretty easy. You just put y squared. So your GCF is 2x squared y squared. So what you're going to do now is divide by 2x squared y squared. Both terms in that group. These cancel. These cancel. So basically I end up with x cubed divided by x squared, which is just x because you subtract the exponents. Negative 2 divided by 2 is negative 1. You can put negative 1 or Yeah, you're going to have to in this case because these cancel and these cancel, and there's nothing left, so you got to put the -1. Okay, you can't just have nothing there. If you're dividing, the same stuff divided by the same stuff is 1. So if there's nothing left, put a 1 for me, okay? Or just say -2 divided by 2 is -1. All right, so that's my remainder. And the GCF of the block in blue was 2x squared y squared. And my remainder was x minus 1. Okay, now I'm going to work with the block in yellow. All right, so the GCF for the block in yellow. Well, what's common? A 3. Do they have any variables in common? Okay, I see that they have some variables in common. I hope you see it too. There's a z and there's a z. They don't each have an x, but I can write a z. And because both of those z's are the same, I just write z. All right, so now I'm going to go and I'm going to divide by the GCF, which is 3z. All right, 3 divided by 3, they'll cancel. Now, if there's nothing left, if everything cancels, I'm going to go back and put 1. Okay, but as you can see, something's going to be left. Z cancels out with Z. Well, what's left? Well, X is left. Okay? All right. 3Z cancels out with 3Z. There's nothing left, but you put a 1. All right, or you could say -3 divided by 3 is -1 and just cancel the Z's out. Okay, that's your remainder for the block in yellow. So when I write my GCF, I know that 3Z is positive. So on this side, I'm going to put positive 3Z times the remainder, x minus 1. So now, I factor out my common binomial factor. And we should all be able to see that the common binomial factor is x minus 1. So I'm going to divide by x minus 1. Divide this by x minus 1. And it should be fairly easy to see what happens. All right. These two cancel. I want that. And these two cancel. Okay. All right. So with that being said, I write the remainder, which is 2x squared x squared y squared, because that's what it leaves me with after I cancel those out, plus 3z. All right, so there's my remainder. Okay, I'm trying to write a little slower. Hopefully it'll do what I need it to. All right, x minus 1 is your common binomial factor. And then your remainder is 2x squared y squared plus 3z. All right, so I want you to pause the video and see if you can do, the next few on your own, and then unpause the video and see if you're getting it correct. All right, I'm going to take a look at number 4. Whew. All right, let's take a look at number 4. You're just checking to make sure you got the same thing that I have, okay? All right, so just look at the block that's in yellow. You have 12 and 21. Well, what goes into 12 and 21? The only factor of 12 and 21 besides a 1 is 3. All right, and they both have a k. So between k cubed and k squared, I'm going to write k squared. And they both have a p. There's p and there's p. That's pretty easy because they're both just p. So I'm going to divide each term by 3k squared p. And I'm just worried about the terms that are in yellow, in the yellow block. Again, that's why it's good to have a highlighter. It helps keep it organized. 12 divided by 3 is 4. All right, so you have 4. These p's will cancel. But k cubed divided by k squared, I'm going to subtract those exponents. 3 minus 2 is 1. So that just leaves me with k to the first, which is k. Negative 21 divided by 3 is negative 7. K squared and k squared are exact. They can cancel. P and P are exact. They cancel. So I write my GCF, which is 3k squared P times the remainder, which is 4k minus 7. Now I'm going to move to the block in blue. The GCF here is 5 between 20 and 35. So I'm going to divide by 5. Now, I hope you all remember at one point I told you all that the leading coefficient, if the leading coefficient is negative, you're supposed to make your GCF negative. Now, I want you to look at 20. What's in front of the 20? Okay, it's a minus sign or a negative. Our GCF should really be negative, but I'm going to work it the way I know most of you will, but I'm going to show you how to fix it, even if you start off working it without pulling out a negative 5 for the GCF, okay? All right, so you're going to end up with negative 4k plus, and it says 7w. I'm going to take this w off of there, okay? Take that w off. I don't even want it on there. It shouldn't be. That's a typo. All right, plus 7. Okay, now look at these two. That's 4k minus 7. That's negative 4k plus 7. So I got a 4k, negative 4k, a negative 7, a plus 4k. So that's what happens if your leading coefficient is negative and you fail to make your GCF negative. Then your common binomial factor doesn't match. Okay, so what do you do if you make a mistake and that happens? What I want you to do is go ahead and change every single thing to its opposite. So if that happens to you, I just need you to write your common factor instead of this being positive. I know this is positive, but I want you to write the opposite. Okay? Then you would just write negative 5. And instead of writing negative 4k plus 7, you're going to write positive 4k minus 7. That's called really your factor, not the negative 1. Okay? So you change this to its opposite. You change this to its opposite and change that to its opposite. Okay? That's what you do if you mess up and they don't match. The signs are different. You start changing this stuff in the blue block or that second pair of factors, you start changing them to the opposites. Now, I really don't like doing mine like that. I would prefer that you were diligent and looking at these signs, and if you saw a leading coefficient that was negative or that first number was negative in your pairing, just to go ahead and make your GCF negative. So I'm going to go back and I'm going to do mine that way because I prefer to have it that way. But I was just showing you what you could do if you forgot. You could go down and then just switch all the signs of the GCF and the signs in the remainder, okay? All right, but I am going to make my GCF negative like it really should be to start off with. Put my box back. Okay. All right, so I'm going to make this negative like it should be. So I'm going to make that a negative 5. So now I have negative 20 divided by negative 5, which is a positive 4, and then bring down your k. And then 35 divided by negative 7, negative 5, which is negative 7. So now this is negative. So I carry it over. Okay? So you write negative 5 and then 4k, your remainder, 4k minus 7. Now you should see a common binomial factor without having to like change anything to its opposite, because you actually made your GCF negative because that leading coefficient right here was negative. That's a negative 20. All right, so you see a 4k minus 7 here and a 4k minus 7 there. So that is my common binomial factor. Common binomial factor is 4k minus 7. So I'm going to factor out the 4k minus 7. And some of you don't need to do all this writing that I'm doing. Some of you won't divide by 4k minus 7 on both sides. You're going to go ahead and write 4k, not 4k. You're going to go ahead and write 4k minus 7. Yeah, that's what you're going to do. And you're going to write 3k squared p minus 5. Some of you just go ahead and write that, okay? If that's what you do, fine. Go ahead and write it if you know. All right. I put 4k minus p. It's 4k minus 7 anyway. Okay, this is going to be my last video because my brain's tired. I have to do more tomorrow. Okay, erase, please. Erase. Okay. All right, these will cancel. These will cancel. Those will cancel. So I'm left with 3k squared p minus 5. And this is your remainder. So you write your common binomial factor, which is 4k minus 7 times the remainder, which is 3k squared p minus 5. Okay. All right, I'll do one more of these. Let's see. I'll do number 5. Okay. Yellow block, blue block. All right, now I'm going to write my GCF between 3 and 15. It's 3. And each one of these, please don't sign me out. Each one of these has an x, so I have x cubed and x squared. So that's going to be x squared. Choose the variable with the lesser exponent. So what I'm going to do now is go through and divide each piece by x squared. Don't worry about the block in blue. 3 divided by 3 is 1, basically, or you can say they cancel each other out. And then x cubed divided by x squared is just x, because you just subtract the exponents. 3 minus 2 is 1. Negative 15 divided by 3 is negative 5. And these will cancel each other out. All right, so you're going to write 3x squared, your GCF, and then your remainder, x minus 5. And then you can go to the block in blue. What do 10 and 2 have in common? Okay, I'm going to show you something about this too. The degree of 10 is 0. We talked about degrees. You probably don't remember, but the degree of every constant is 0. The degree of this 2x squared is, please don't sign me out. The degree of this 2x squared right here is 1. All right, so really the 2x squared is the negative 2x is the leading coefficient. Can I get this off? Did it just freeze on me on the last part? Okay, so I'm going to just say the GCF is 2 because I don't know what to do to get the marking back. It won't let me do it. All right, so the GCF is 2. I want you to see some. I'm going to try to erase in a minute. But the leading coefficient is not the 10. The leading coefficient is the negative 2 because negative 2x has a degree of 1. So when you write it in standard form, you really should have negative 2x plus 10. Okay? Which tells me my GCF shouldn't be 2. It really should be negative 2. So I'm going to go ahead and put the negative 2. Okay? All right. This is the leading coefficient. The negative 2 is. Because it has a degree of 1. And 10 has a degree of 0. And if you put them in order, the degree of 1 beats the degree of 0. So that's really the way it should be. All right, so I have 10 divided by negative 2, which is negative 5. Negative 2 divided by negative 2 is positive 1, or they cancel each other out, or you could just put 1x or just x. Okay? All right, so somebody's saying, well, those aren't the same. Yeah, yes, they are, because if you look, this, let's see if it'll let me get, this is a positive x, and that is a positive x. This is a negative 5, and that is a negative 5. So they're just written backwards, but it's still x minus 5, okay? Negative 5 plus x is still the same as x minus 5. Let me go ahead and scratch it out because the GCF is not really 2, it's negative 2. All right, so when I write this, I'm going to write negative 2. And instead of writing negative 5 plus x, I know it's the same as x minus 5. So I'm just going to write it like that. And then my common binomial factor is simply x minus 5. So I'm going to divide both by x minus 5. So these cancel. It won't let me do anything else besides what's on here. These will cancel. So that leaves me with 3x squared. These will cancel, leaving me with negative 2, and that's my remainder. I'll see if I can write. So in factor form, it's going to be x minus 5 times 3x squared minus 2. And guys, yeah, I'm not going to do the last one because I don't want to have to deal with this thing not doing the way what it's supposed to either. All right, but I hope you get the idea of how to factor by grouping. You got to have 4 terms. Then you group them in pairs. And then you factor using the GCF like we did in the previous lesson. Then you find that common binomial factor and factor it out, okay? All right. The next lesson is pretty simple, but I'm going to postpone doing that until tomorrow. But it's really easy. All right, guys, that's it.